we're working with measurements, and today we're going to be looking at surface area and volume of spheres. Okay. So the main objective is how to calculate surface area of spheres. Mind you, you're given the formula for it. Find the volume of spheres, you're given the formula for it. Our challenge is going to be how to manipulate or modify it so we can get the surface area and volume of hemisphere as well. Okay. Also, how to determine the unknown dimensions of a sphere. So meaning that they could give you the volume and then ask you to find the radius. And they can do the same thing for surface area and ask you to find the radius. Okay. And then also to be able to find surface area of composite figures, meaning if you put two figures together, like a cylinder and maybe a hemisphere, how to find volume or surface area of that. So first of all, just understanding what these formulas are. So first of all, sphere, there's no net diagram as we've been looking at them. There is formulas given to us for the surface area. So it's kind of like a sphere is like a round ball, or I like to use a watermelon for example. So if we're talking about surface area, we're talking about the green part of the watermelon. Okay. So that formula is given to us, and you'll find that on your formula sheet. The surface area formula is 4 pi r squared. Same thing with the volume. Volume is the inside capacity of it. So if you were to take out all the red parts of this watermelon, what you actually eat in there, that would be the volume of it. So the volume of the sphere is also given to us, and it's 4/3 of pi r cubed. Okay, so this would be your unit squares, and this would be then your units cubed. Okay, so that's for the surface area. That's our sphere right here. Now, if you were to cut the sphere in half, that is called a hemisphere then. Okay. So now we have a hemisphere here. So that means it's half of your sphere. Okay. That means half of the sphere. How does that change our formulas? Well, first of all, the volume is simply also halved. So if you have hemisphere, it is half the volume of a full sphere. Okay, so half the volume of a total sphere. So you could actually just calculate your volume of a full sphere, pretending it's a full sphere, and then just divided it by 2. So you could get the volume of a sphere, and then simply then just go ahead and divide by 2. You don't really need a fancy formula for it. But if you are looking at a formula for it, so 4/3 pi r cubed divided by 2 would become 2/3 pi r cubed. So I would hardly ever use it. This is not given on the formula sheet. I would just remember that take my volume of my sphere and then divide by 2. It's simply half of it. Surface area is a little bit more trickier. So we have to kind of remember with that one. Surface area, because when you cut a sphere, so if we're talking about this watermelon, when you cut a sphere, you do have half the surface area here. So this is half the surface area of this normal sphere. But what you also get is this red part over here. Okay, so this red part here that you see is a new circle that you exposed. So you add to that the circle. So that's the red part in here. Okay, so the formula would then be half the surface area of a sphere. So normal sphere's surface area is pi r squared. So that's what it would become, 2 pi r squared. But then, because that's for this part, but then when you add that when you add that circle on top of that, and that normal circle is pi r squared. So you have to remember that you do the same thing like volume. You take half of it, but this is something that you need to add on top of it, the circle that you have over here. Okay, So that means the total ends up becoming 3 pi r squared. You could keep it in this expanded form, but as long as you remember to always add the circle onto hemisphere. So that's the one thing that we have to remember in this. Our first example in the book also goes through this. So let's take a look at that in the next video.